In this video, we are going to find the cosine of x plus y. And we're going to find it in terms of x and y. So basically, what is the cosine of x plus y in terms of x and y? That's basically what we're going to try and find in this video. Now, remember, when we're doing this, we've got to remember that x and y are really just angles, right? Those are just angles. And since they're angles, I'm actually going to switch it up a bit. Instead of x and y, I'm going to use alpha and beta, because Greek letters tend to be associated with angles. And so that's the reason why I'm going to do that, just so it looks nicer. Now, how do we even find the cosine of alpha plus beta? I mean, how would we even start by doing that? Now, remember, we're dealing with angle measures, and so maybe what we would want to do is draw the angles out first. So let's just do that. So I'm just going to start out by drawing something that's sort of like a coordinate plane, right? Something like this. So I'm going to first start out by drawing the angle alpha. So do that, I'm just going to draw alpha. Let's just say I draw alpha right here. So this right here is going to be the angle alpha, right? This angle right here is angle alpha. And I'm actually going to draw angle beta right next to alpha, right? I'm going to draw beta right next to alpha. And I'm actually going to draw it right here. I'm going to draw it right here, right next to alpha, just like that. And basically, this angle right here is angle beta. Now, we've drawn alpha and beta, and the reason why I drew alpha and beta right next to each other is because now we have alpha plus beta, right? We have the angle alpha plus beta on our picture as well. Now, if we want to find the cosine of alpha plus beta, the next thing we probably would want to do is draw right triangles, since we're dealing with trigonometry, right? Cosine. So let's draw right triangles out of these angles right here. So to draw a right triangle that uses alpha, basically all we have to do is bring this line downward like that, right? And we have a right triangle where one of its angles is alpha. Next, I'm going to draw a right triangle that has beta in it. And the way I do that is, well, basically what I actually have to do is I actually have to extend this line a little bit. I'm just going to extend it about that much. And I'm going to take this part of this, I'm going to extend it downward this way so that it's perpendicular to that line, because if it's perpendicular, forms a right angle, and so now we have a right triangle. And this right triangle right here uses the angle beta. So we have made two right triangles that use alpha and another one that uses beta. And the next thing that we're going to want to do is we're also going to want to make a right triangle that uses alpha plus beta. And to do that, all I have to do is extend this line downward so that it basically reaches there. And so as you can see, this right triangle right here uses alpha plus beta. So we have made three right triangles, right? We've made one that uses alpha, we've made one that uses beta, and we've made one that uses alpha plus beta, right? So those are the right triangles that we have made. However, there's also a fourth right triangle that we don't want to forget, right? This fourth right triangle is very, very important, right? As you can see, we also have another right triangle that we made. But wait a minute. What angles does this right triangle use? What angles does it use? Well, if you notice right here, we have angle alpha right here. If this angle is alpha, then what angle is this? Well, since it's a right triangle, this angle right here is just 90 degrees minus alpha, right? That's that angle, right? Because it's a right triangle. So if this is alpha, then this one just has to be 90 degrees minus alpha. Now, for this angle right here, basically this angle and this angle, they're vertical angles, so they have to be the same. That means this angle right here is also 90 degrees minus alpha. And that means, well, we know this angle And so that means we can find this angle, because remember, it's part of the same right triangle. That if this angle is 90 degrees minus alpha, then this one is just alpha. So this angle right here is actually just alpha. So it turns out that this right triangle right here uses angle alpha. Right? So both this right triangle right here and this right triangle right here, both of them use alpha. All right, so now that we know that, the next thing I'm going to do is I'm going to start out by labeling my side lengths, right? I'm going to call this side length A. I'm going to call this one right here side length B. I'm going to call this one right here side length C. I'm going to call this shorter one side length D. I'm going to call this long one right here, I'm going to call that one E. I'll call this short one right here F. I'm going to write F right there. And I'm going to call this one on the bottom G. So, we have labeled all of our side lengths, and we've labeled all the angles that we need to know, right? So now delete this circle right here. Right, we've labeled the side lengths and the angles that we need to know. So, our goal is to find the cosine of alpha plus beta. And we're basically going to use this picture right here to find it. Now, basically cosine of alpha plus beta, right? From the picture, what is the cosine of alpha plus beta? Now, when we're looking at the cosine of alpha plus beta, the angle that we're going to want to use is alpha plus beta. So the right triangle that we're going to focus on is this right triangle right here. This right here is the right triangle that we want to focus on. So the cosine of alpha plus beta is adjacent over hypotenuse. It's G over A. So basically, cosine of alpha plus beta is G over A. However, of course, this is not our final answer, right? Why would this be our final answer? It's not, right? Our goal in this video is to find the cosine of alpha plus beta in terms of alpha and beta, right? That's what we want to find in terms of alpha and beta. That means that we're going to need these side lengths right here to cancel out in some sort of way. And the way that we're going to do that is we're going to write G in terms of A. That's what we're going to do, right? That's the ultimate thing that we're going to do. And basically, I'm going to write that down. If we do that, then that means we can have A cancel out with A up here, because remember, G is going to be in terms of A. We'll get G and A to cancel out, and so that means we'll be left with alpha and beta, right? Because we're trying to get side lengths to cancel out. Okay? So, to find G in terms of A, how do we do that? How do we do that? Now, basically, we're going to use the right triangles that we have made to do that. However, we cannot use this right triangle right here, because we're already using that right triangle to solve the problem, right? Because that uses alpha plus beta. We can't use that triangle. We can only use the other right triangles that we made. So, the first thing that we're going to do is we're going to write G in terms of E. And we can do that, right? We can write that in terms of G using this right triangle right here. So we can do that. And the way that we're going to do that, to write G in terms of E, is using this right triangle, which uses alpha. The cosine of alpha is equal to G over E. So, cosine of alpha equals G over E. I meant E, right? It equals G over E. Now, if we solve for G, we get G equals E times the cosine of alpha. Remember, our whole goal is to find G in terms of A. So that means, in order to do that, we need to change E. We need to change E. we need to write what E is in terms of A. Can we do that? I mean, let's look at our picture. I mean, now it's when we can't directly write E in terms of A because they're not part of the same right triangle. So what we're actually going to do is we're going to first write E. We're going to write E in terms of E plus F and F. Because, well, we know basically that E is equal to E plus F minus F, right? I mean, that makes sense. The F's cancel out and we're left with E. But really, we know that E plus F is a side length and F is a side length, right? We have E plus F right here, which is basically this side length right here, and we have side length F right here. If we do E plus F minus F, we will get side length E, right? So we'll get E. The thing is, if we want to do it that way, then we have to be able to write E plus F in terms of A, and we have to be able to write F in terms of A. So let's start out by just writing E plus F in terms of A. So let's do that. So if we look at our picture right here, if we want to write E plus F in terms of A, they are part of this right triangle right here, which uses the angle beta. The cosine of beta is equal to E plus F over A. Okay, so let's just write that down. The cosine of beta is equal to E plus F over A. If we solve for E plus F, we get E plus F equals A times the cosine of beta. So that's E plus F. Next, we have to find what F is in terms of A. So to do that, let's go back to our right triangle here. Or let's just go to our picture right here. So basically, we have to write F in terms of A. And, well, the thing is, F and A are not part of the same right triangle. So what can we do? Well, notice how we can write F in terms of B, and then we can write B in terms of A, right? So let's start out by just writing F in terms of B, because basically F and B are part of this right triangle right here, right? Which uses alpha. So the tan of alpha is equal to F over B. If we solve for F, we get F equals B times the tan of alpha. Now, the next thing that we need to do is we need to find what B is in terms of A, so that we will have F in terms of A. So, we have to find what B is in terms of A. If we look at our right triangle, we have B and A. Notice how B and A are both part of this right triangle right here, which uses beta. The sine of beta, right, the sine of beta is equal to B over A. So, just write that down. The sine of beta is equal to B over A. If we solve for B, we get B equals A times the sine of beta. So, the next thing that we have to do is we just have to substitute, right? This right here is B in terms of A. The next thing that we have to do is take B and place it in here. Basically, we have F equals B tan alpha, and we just have to rewrite B as this. So basically, we get A sine beta, right? A sine beta, which is just B, and we take that and multiply it by the tan of alpha. So that is basically F in terms of A. So we have found E plus F in terms of A, and we have found F in terms of A. Using those two things, we can now find E in terms of A. Because, well, let's go to the next page. basically, let's just recall, E is equal to E plus F minus F. And E plus F is just A cosine beta. So E plus F is just A cosine beta. And F is A sine beta tan alpha. So we have A sine beta tan alpha. So this is what E is in terms of A. We have found E in terms of A, right? Now, why are we finding E in terms of A? Why are we doing that? Because remember, our whole goal is to find G in terms of A. And we can't do that if we can't find E in terms of A. So that's the reason why we're doing that. So basically what we're going to do is we're going to take this and substitute it into here, right? Because then we will have G in terms of A. So let's just rewrite what we had right here. G equals E times the cosine of alpha, right? That's what we had right here. E times the cosine of alpha. All we're taking is we're taking this E and substituting it into here, right? So G is equal to, right? Let's just take E. E is just this stuff right here. A times the cosine of beta minus A times the sine of beta times the tan of alpha. That is E in terms of A. And we're just taking that and multiplying it by the cosine of alpha. Now, just to make this look nicer, I'm just going to switch these around. So we have cosine of alpha in front, because most people are more comfortable with seeing it that way. Right, seeing it like this. So as you can see, that is basically what we have. This is G in terms of A. All right, so we have found G in terms of A. Now we're ready to solve this problem. So let's do it. Okay, so basically we're ready to take what we originally had. All right, we're ready to take what we originally had, which is cosine of alpha plus beta, which we said was equal to G over A. And remember, all we wanted to do was find what G is in terms of A, so we can get the lengths to cancel out, to get this stuff to cancel out. And we found G in terms of A. We found it. So we're ready to substitute that in. So this is what we have for G, and this is all divided by A. All right, so now that we have that, you might be thinking, okay, we need A's to cancel out. Some of you might be like, how do the A's even cancel out? The way I'm going to show you that is I'm just going to factor out A. Right? I can factor out A right there. Basically, what I can do is I can just factor out A in the numerator, and I get A cosine alpha times, and what's left inside the parentheses? We have cosine of beta minus the sine of beta times tan of alpha. And this is all divided by A, which is equal to the cosine of alpha plus beta, and that's that. Notice how A cancels out. And we're no longer dealing with any of the side lengths that we created here that are in red, right? We're not dealing with any more of the side lengths. It's only the angles now, right? We use the side lengths to help us get to this point, right? But now all we have is this stuff right here, which is just angles alpha and beta. So we're ready to find cosine of alpha plus beta in terms of alpha and beta. And so what we're left is just what's in the numerator, which we have the cosine of alpha times the cosine of beta minus the sine of beta times the tan of alpha. All we have to do now is just distribute cosine of alpha across this parentheses. And so let's do that. If we do that, we get the cosine of alpha times the cosine of beta minus, and what we have here is the sine of beta times the tan of alpha, and that's multiplied by the cosine of alpha. So multiplied by the cosine of alpha. Now, the thing that we have to notice here is that the tan of alpha can be rewritten, right? Right, remember, tan is just sine over cosine, right? The tan of alpha is just the sine of alpha over the cosine of alpha, right? This is one of the trig identities, right, that we already know. So tan alpha is just sine alpha over the cosine of alpha. Cosines of alpha cancel out. And that leaves us with just this. And we're left with the cosine of alpha, which is the cosine of beta, minus this. And we can flip this around. We can say it's sine alpha times sine beta. So sine alpha times the sine of beta. And this is equal to, right, this is both equal to cosine of alpha plus beta, cosine of alpha plus beta. This, just going to move this down, this right here is our final answer. This is what we have with cosine of alpha plus beta. This is what it is. We have found the cosine of alpha plus beta in terms of alpha and beta. So this is basically it. And in the beginning of the video, I had cosine of x plus y. If you want to see what it looks like that, basically, instead of alpha plus beta, I'm just going to use x plus y. So the cosine of x plus y, if we were to change that up, just the variables, it's just cosine of x, it's the cosine of y, minus the sine of x times the sine of y. And that is what we have.